The electromagnetic spectrum is something that always comes up when we're talking about light, and particularly energy. But before we can actually talk about the spectrum, we need to review a little bit about waves. So here's a general wave. Just a reminder, the very top of the wave is considered the crest, the bottom is the trough, and the distance between either two tops or two bottoms, so two crests or two troughs, is called the wavelength. So it's the amount of space, the distance it takes to make a full cycle from the top to the bottom and then back up to the top. Wavelength is a measure of distance. It can be measured in meters, nanometers, centimeters, kilometers, any of our typical distance measurements. If you have a wave with a very long wavelength, so lots of space, you have a low frequency. That means it's hitting a single point few times in a certain amount of time. That also means it has low energy. So you imagine a wave going like this. Very low frequency, not a whole lot of energy. Now, if we have a short wavelength, a wave that's moving really fast, it has a very high frequency and therefore a very high energy. So high frequency, high energy, low frequency, low energy. Now let's talk about the actual spectrum. So we can get a lot of information from the actual electromagnetic spectrum. So as you move from left to right, you are increasing in wavelength. So you're starting with really fast waves, and then the wavelength's getting longer as you move across the spectrum. This means that as you're increasing wavelength, you're decreasing energy, or they go in opposite directions. This way increases wavelength, this way increases energy. So the far left side of your electromagnetic spectrum is going to have your highest energy, and the far right side is going to have your lowest energy. So our high energy, we know gamma rays, think the Hulk, Bruce Banner. Then we have X-rays. That's why at the dentist or the doctor's office they put those lead cloths over the parts of your body that they want to protect, because X-rays are dangerous. Then we have UV. That's what gives you sunburns or tans, none of which are good for you, cause skin cancer. Right past the UV, we get to the visible. So this little tiny range right here is everything we can see. That's why it's called the visible spectrum. And it starts with purple. Purple has the highest amount of energy. And then it goes blue, green, yellow, orange, red. Now, my colors, for the sake of not ruining my markers, they're pretty distinct sections. It's really a whole blur of colors. It's a very continuous spectrum. So purple blurs into blue, which blurs into green, into yellow, orange, and red. So red has your lowest energy. Purple has your highest energy. And those wavelengths range between 4 times 10 to the negative 7th meters and 7 times 10 to the negative 7th meters. Once we get past the red, so remember we're increasing wavelength, so we're getting lower energy. We hit infrared, or IR. And then we have, so IR is what you can detect heat with. And so then we end up with radar is next. And then your FM radio signals, your TV, your shortwave radio signals, and then your AM radio signals. The AM waves are 1 times 10 to the 4th meters in wavelength. That means in between two peaks, you have 1 times 10 to the 4th meters of space. Really long wavelengths, really low energy. So that's the electromagnetic spectrum.